Hi everyone, I'm Neha. I'm a software engineer at Yugabyte, and today I'm going to go over a new feature that we've added called co-located tables. This is something that's available in beta in Yugabyte 2.1 version. If you look at relational databases today, a lot of times you will end up having a large number of tables and indexes. For example, it's not uncommon for a relational database to contain 100 tables and then each table having one or more indexes, which brings like the total relation count to be about 300, 400 per database. In Yugabyte, we are a scale-out database, so what ends up happening is each table will be split into a number of shards. So if you have, let's say, 100 tables, each table split into, let's say, 10 shards, right? You automatically now have a large number of shards that you need to take care of. Each shard comes with its own overhead. For example, it puts more CPU, disk, or network overhead on the cluster. A lot of times, some of these tables are going to be very small in size. Some even are static tables that don't change over time. So for example, you might have a table called category in your database, which is mostly static information that doesn't change much. So we wanted to provide an ability to be able to co-locate such tables onto a single tablet or onto a single shard. So co-located tables is just that. It's an ability for you to group certain smaller tables into a single tablet or shard and use separate shards for the tables that you actually want to scale out. So in your database, if you have 100 tables, let's say 95 of those are small, they can all be co-located on a single shard, and the remaining 5 can be those scale out tables which actually have their own set of shards. Now, what are some of the use cases where co-location will be useful? One example is a geo-distributed application or simply an application that needs high availability, but the data set size is small, let's say 500 gigs or lesser. An example could be an identity service, that's geo-distributed but doesn't have a very huge data size footprint. Another example could be a database that has a large number of tables, but only a few of those actually need to scale out. So for example, IoT applications which may maintain information in a number of tables, but only few of those contain tracking events type of data which actually needs to scale out. So in such applications, the smaller tables can be co-located on a single shard and the other tables can actually use their own set of shards and scale out. And the third one is you might have is a use case where you have a number of databases. So it's a multi-tenant service. Let's say each database has a large number of tables that we want to support, but the data set size for each database is small. So you might have, let's say, 1,000 databases, one database per customer, but each database size ends up being, let's say, 500 gigs or lesser. So some of these three use cases, for example, can end up benefiting from co-location. Obviously, there are some trade-offs. So co-location gives you very high performance because now all of your data is stored on a single tablet. So you don't incur any network reads when you're doing joins or if you're doing index lookups, because everything is all located on the same table, on the same shard. Then from the motivation itself, the reason why we added the feature was to be able to support a large number of databases and tables. So you can do this very easily with co-location because you're automatically reducing the number of tablets and you're reducing the overhead that's put on Yugabyte cluster. The disadvantage is you will end up having lower scalability for your table because now since all of your data resides on the same shard, you're now bounded by how much data can fit into one shard. Of course, this is only applicable until you remove the table out of the co-location tablet. So once your table data splits into another tablet or you manually remove it out of your co-location tablet, until then you will have the lower scalability problem. So let's look at how co-located tables work in practice. So here we have a 4-node Yugabyte cluster. You have your client apps which are using YSQL to connect to the cluster. Now, the first thing that you will do is you'll run a create database command which says that co-located is equal to true. So you're saying that you want to co-locate all the tables that are part of this database. Now, once you run the create database command, what this will do is it will end up creating one tablet for that database. That tablet is now replicated across, it's three-way replicated, so it's present on 3 different nodes. And now what ends up happening is, because all your data is in a single shard, you don't have any network latency for multi-shard transactions or multi-row transactions, right? Now here's a simple example of how you'll use it in practice. So you have a create database statement which will say with collocated equal to true. So that will end up creating one shard for that database. Now you run your create table statements as you usually would. It's a simple create table. Now create table category table will end up using the same data shard that you created for the database. Similarly, products will end up using the same shard that you created for the database. Now let's say that you have a large table which you want to opt out of collocation. You can do that using create table with collocated equal to false. Now this will cause orders table to not use the shard that was created for collocation demo database and instead have its own set of shards. So I'm going to just go over a simple demo for how to use collocation and some of the benefits that you can get with collocation. So this slide is just to explain the setup that I've used. So it's a pretty simple. I've created one database called collocation demo with collocated equal to true. I've created 2 tables within that, test1 and test2, which are collocated. And then I've created 2 tables, opt out test1 and opt out test2, which are not collocated. They have opted out of collocation. And then I'm going to run some simple queries on it. So I'm going to run some aggregate queries, select count, simple select count star from table. I'm going to do some table scan queries, show an example of what happens when you write to a single table, and an example of what happens when you're trying to join data from multiple tables. So with that, let's move on to the demo and show you the setup and how to run these queries. So this is the cluster that I've created for the demo. If you look at, this is a geo-distributed cluster. So you have, one node that's in Europe, one node that's in US East, and one node that's in US Central. Here's like a UI which shows all the tables on in the database. So we have 2 tables, test1 and test2, which are collocated on the same shard, and then we have 2 opted out tables. So if you look at test1, you will see that it has it's using one shard, this shard. And if you look at test2, you'll notice that we are using the same shard for test2 as well. So if you look at test2, it's using the same shard. Whereas if you look at the opted out tables, you'll see that they have their own set of shards. Now notice that the collocated table ended up having one shard, whereas the opted out tables have multiple shards, and that's intentional because the reason why you want to opt out a table is because you want to scale that table out. So by default, Yugabyte will end up sharding that table into multiple tablets. Now let's try to, with this kind of setup, let's try to run some of the queries that I had spoken about previously. So for example, let's look at a select count star from table, right? So we're going to try to select it from test1 and we're going to try to select it from the opted out table. So here I've used YSQL sh, which is a command line utility that we can use to connect to Yugabyte and run queries. Okay, so let's give this some time again. So we have select count star from a table, right? So there was a little bit of a refresh issue, so I'm starting the test from here. So let's say you do a select count star from a table test2, which is a collocated table. You're seeing the time to be around 700 milliseconds. Now let's try this from an opted out table, right? So you have an opt out test table. So this, as expected, took a little bit longer. We estimated to be about 2x longer than what a collocated table would be. So around 2 seconds is what it ended up taking. Now let's run a similar query with scanning a table, right? So you're doing a simple scan and just selecting 10 rows from the table. This is a 1000 row table, and of which you're selecting 10 rows. Okay, so this again took about 700 milliseconds, and now I'm going to try the same query with opt out. Okay, this surprisingly took lesser time. But okay, so I think we can see this more deterministically when you're seeing, when you have a much larger data set. Now going back into an update, let's try to update the collocated table. Okay, so 1000 rows were updated in about 600 milliseconds. And now let's try to update the non-collocated table. So this ended up taking a much longer time, because now what you have to do is your writes are now going across regions, right, to multiple shards. So all of your tablet leaders, for example, are going to be in different regions, so your writes end up incurring that penalty while writing. Let's now look at a join query. So this is joining two collocated tables and getting 10 rows. And now let's try to run the same query, but with on the non-collocated tables, on the opted out tables. So it took slightly longer. So yeah, so I think that's kind of the gist of what collocation is and where it can be useful. Thank you very much.